Hi friends, welcome back to Edupedia World. In last lecture we saw the theory about pulleys and pulley system in the previous two lectures. But we did not go into any numericals, we just saw the theory. So today's lecture will be focused on numericals on pulley. We will try to see different numericals and understand and concrete our understanding about the theory of pulley and pulley systems. So let us get started with today's lecture. The question states, this first question which we are going to discuss about the pulley system states that a woman lifts a bucket of water which has mass of 10 kg and she has to apply a load of 150 Newton. G is given to be 10 meter per second square. We are also asked to calculate mechanical advantage, velocity ratio and efficiency. And lastly, the question mentions that C uses a single fixed pulley. So this is very important. Single fixed pulley is being used. Let me draw the diagram to see how this will work. This will be my pulley system, and here will be the load, which will be 150 Newton, rather 10 kg, 10 kg acting downwards, and here I will apply effort of 150 Newton. This should be effort, apply a effort. So the effort is 150 Newton, the load is 10 kg, and this is the single pulley system. So the first step we need to do is that we need to find out the load. The load will be equal to the mass times the gravity, which is 10 times 10, and that will give me 100 Newton. So the load is 100 Newton. The effort is 150 Newton that is applied to lift the bucket of water. The first part asks me to find the mechanical advantage. I know that the mechanical advantage is load upon effort. I will simply replace it 100 upon 150, and that gives me 2 by 3 as the mechanical advantage, or if I write it in decimal form, 0.67 approximately. So this is the mechanical advantage which we get. The second part asks us to find the velocity ratio. Now what is the velocity ratio? Velocity ratio is the distance moved by effort upon the distance moved by load. This is the basic definition of velocity ratio. Now if we see here and imagine that the effort moves down by, let's say, 1 meter, then how much is this load going to move? Obviously, since the whole rope is a continuous rope, 1 meter over here will lead to a movement of 1 meter of the load in upward direction. So we see that the effort and load moves by equal distance. Therefore, the velocity ratio will turn out to be 1. Okay, now the third part asks us to find out the efficiency. We know that the efficiency of a system, of a pulley system, is mechanical advantage upon velocity ratio. We can simply replace it 2 by 3, this whole divided by 1, that will be 2 by 3 in fraction, or into 100 if we do, we will get 66.7%. Approximately. I took another decimal place here. This is actually equal to 66.6666. Keeps on going, but I can approximate it as 66.7%. So what we see here is that we get an efficiency of around 66.7%, which means that there are frictional losses in the system, and there is loss maybe due to the weight of the rope itself, which we have considered to be 0, which in practicality will not be 0. So this question applies the concepts for the single fixed pulley. Now let us see another question. This second question deals with a block and tackle system. We have a block and tackle system, that is, there will be two blocks of pulleys, one the fixed block and the other the movable block. And this block and tackle system has 7 pulleys. So there are 7 pulleys in the system, and it says that an effort of 100 Newton is required to lift 350 Newton of load. Let us write down what all information is provided. We know that the effort is 100 Newton, and we know that the load is 350 Newton, and we know that the number of pulleys is equal to 7. Just for the sake of revising the theory, since this is a block and tackle system with odd number of pulleys, the block at the top, that is the fixed block, will have 4 pulleys, and the movable block will have 3 pulleys. That is what we studied in the theory. Now back to the question. We have been given this information, and we are asked to find the velocity mechanical advantage to begin with. The mechanical advantage we know is the load upon effort. Okay, we know that mechanical advantage is load upon effort. This is the fundamental definition. So from there we will calculate, and we find out that the mechanical advantage is 350 Newton upon 100 Newton, and that turns out to be 3.5. So we get the first part of the question. Now the second part of the question asks us to find the velocity ratio. Now velocity ratio is the ratio of the distance moved by the effort to the distance moved by load, dE upon dl. And we read in the theory that the velocity ratio for the block and tackle system is equal to the number of pulleys in the system. So if you remember that idea, then we can directly write that the velocity ratio is 7. In case you do not remember this idea, then how do we go about it? What we can do is we can think about a 3 pulley system and actually calculate the formula. Now what do I mean by that? 3 pulley system will have 2 pulleys here and 1 pulley here. This will have the load here, and this will be the fixed thing. There will be the further, it goes like this again, and here is the hook on which this comes. Now if we see this 3 pulley system, what we'll find is that if the load moves by a distance dl, then if this moves up by dl, then this, and this, all these 3 will slack by a distance dl. This will become loose by a distance dl. To counteract for that, this section of the rope, that is where the effort is, will have to move 3 times dl. Okay, so as to counteract the slack of dl in each section. So this will be 3 dl. As a result, the dE upon dl will be 3 dl upon dl, that is 3, which is equal to n. So here again we found out that the velocity ratio is equal to the number of pulleys. So just in case you do not remember, you can calculate like this. Now since I already knew that, I directly wrote it to be 7, that is equal to the number of pulleys. Now the third part of the question asks me to find the efficiency. Efficiency is mechanical advantage upon velocity ratio. This is the basic definition of efficiency. So if we replace the values, we get 3.5 upon 7, which is 0.5, and in terms of percent, it is 50%. So this system is just 50% efficient. That is, we are actually wasting 50% of the energy. Now finally the fourth part asks us, under the same efficiency condition, that is there is 50% efficiency, how many pulleys will be required to lift 500 newtons of load using 100 newton of effort. So again the load is changed to 500 newton, the effort remains 100 newton, and the mechanical advantage will be load upon effort. Sorry, this has to be effort. Load upon effort, which turns out to be 5, and velocity ratio is equal to the number of pulleys, that is n. Efficiency is equal to velocity mechanical advantage upon velocity ratio, which is 5 upon n, and that is equal to 0.5 because it says under same efficiency condition. 0.5. This will give me n is equal to 5 upon 0.5, which is 10. So I get that under this condition, that under the condition of same efficiency, lift 500 newtons using 100 newton of effort, I will require 10 pulley system. So 10 pulley system is required to do this. Okay, we have completed this question. We understood the idea behind this. Let us jump into a final question and wrap up our chapter of pulley and the whole section of machines with that question. The last question of the chapter says that we have a system of pulley which has one fixed pulley and 4 movable pulley, and we require to lift a load of 1600 newton. So this is the system in which we have multiple movable and one single fixed pulley. So this is the first type of combination of pulleys that we discussed in the previous lecture, and we are told that the efficiency is 80%, and we have let us write down the load is equal to 1600 newton, efficiency is equal to 80%, and number of movable pulley n is equal to 4. So from the lecture we know that the velocity ratio for such a system is 2 to the power n, where n is the number of movable pulley. So the velocity ratio for our question at hand will be 2 to the power 4, which is 16. This means that the effort will have to move 16 times that of the load. Now the second part asks us to find mechanical advantage. If the efficiency were 100%, then the velocity ratio and the mechanical advantage would have been same. But the efficiency is 80% rather than being 100%. So we'll use the relation efficiency is mechanical advantage upon velocity ratio to find the mechanical advantage. Here we know the efficiency and the velocity ratio. So by mechanical advantage can be alternatively written as efficiency times the velocity ratio, and that will turn out to be 0.8, that is 80%, and the velocity ratio is 16. So if we calculate this, it comes out to be 12.8. So the mechanical advantage for the system at hand is 12.8. Now the final part asks us to find the effort required. We know that the load is 1600 newton. Mechanical advantage is defined as the load upon the effort. This is the basic definition of mechanical advantage. From here we can find out the effort, and that will be equal to the load upon mechanical advantage, which will be 1600 upon mechanical advantage is 12.8, and that will turn out to be 125. So 125 Newton. Therefore, the effort required in this case will be 125 Newton. Imagine that the efficiency was 100%. Under that scenario, what would have been the effort required? If efficiency was 100%, then the effort required would be L upon ma again, but the mechanical advantage would have been velocity ratio, and we would have got 1600 upon 16 and 100 Newton. But this is not what the question asks. The question asks the effort required under 80% efficiency. So we got 125 Newton. Okay, so with this final question, we come to a conclusion of the pulley system and the machines as a whole. I hope you have a better understanding and a much clearer idea about the whole machine system. Next up, in our next lecture, we will hopefully see some calorimetry and some concepts about heat and temperature. Till the next lecture, have a great day. Goodbye.